In this question, it is given that let alpha and beta be the roots of this equation, where alpha is more than beta. For all positive integers n, define an as this, where n is greater than equal to 1, b1 equal to 1, and bn is equal to an minus 1 plus an plus 1, where n is greater than equal to 2. Then which of the following options is oblique are correct? As I have told you many times that in case of multiple answer question, you should always start checking the choices from the easiest choice, because many times examiner gives the choices in such a way that result of one choice is used in the other choice. It's clear that choice D is very easy to check, because when I will put the value of an here, you will be getting two infinite GPs, one of alpha and other of beta. What I mean to say, you will understand when I will do the question. It's clear that left hand side is alpha to the power n minus beta to the power n upon alpha minus beta into 1 by 10 to the power n. That is, this is equal to 1 upon alpha minus beta sigma n is equal to 1 to infinity alpha by 10 to the power n minus sigma n is equal to 1 to infinity beta by 10 to the power n 1 upon alpha minus beta. Clearly both are infinite GPs. In this case, first term is alpha by 10 and common ratio is also alpha by 10. Therefore, alpha by 10 upon 1 minus alpha by 10 minus beta by 10 upon 1 minus beta by 10. This is equal to 1 upon alpha minus beta, and I get alpha upon 10 minus alpha minus beta upon 10 minus beta. That is equal to 1 upon alpha minus beta, alpha into 10 minus beta minus beta into 10 minus alpha upon 10 minus alpha into 10 minus beta. Clearly this is equal to 1 upon alpha minus beta 10 into alpha minus beta minus 2 alpha beta upon 10 minus alpha into 10 minus beta into alpha minus beta. That is, you will be getting 10 upon 10 minus alpha into 10 minus beta. After this step, most of the students will do it in this way. They will open this bracket, and after opening, they will multiply these two brackets, and after multiplying, they will put the value of alpha plus beta and alpha into beta. Agreed, that is not wrong, but the way I'm going to tell you is smart way. And in case if there are three terms, in that case my way will be very smart as compared to opening the bracket if there are three brackets. What I mean to say, see, to find the value of this, because I know that alpha and beta are the roots of this, hence this can be written as x minus alpha into x minus beta. And if I want to find the value of 10 minus alpha into 10 minus beta, put x equal to 10 in this equation. We'll get 10 minus alpha into 10 minus beta equal to 100 minus 10 minus 1, that is 89. Hence we have got the value of this as 89. Therefore I get the answer 10 by 89. Hence I can say D is correct choice. And now I can check C or B. A is slightly more tough. Therefore I will be checking this in last. Out of these two, both are equally tough. I can check any one first. So I check B. According to definition, Bn is equal to An minus 1 plus A n plus 1. This is equal to alpha to the power n minus 1 minus beta to the power n minus 1 upon alpha minus beta plus alpha to the power n plus 1 minus beta to the power n plus 1 upon alpha minus beta. This is equal to alpha to the power n minus 1 into 1 plus alpha square minus beta to the power n minus 1 into 1 plus beta square upon alpha minus beta. And clearly, because alpha is a root of this, therefore alpha square is equal to alpha plus 1. Hence I get alpha to the power n minus 1 into alpha plus 2 minus beta to the power n minus 1 into beta plus 2 whole upon alpha minus beta. This is equal to, because the value of alpha and beta can be found by finding the roots of this. Bigger root will be alpha and smaller root will be beta, because it is given that alpha is greater than beta. Clearly the roots of this are x equal to 1 plus minus 1 plus 4 by 2. That is 1 plus root 5 by 2 and 1 minus root 5 by 2. Therefore I will name this as alpha and I will say this as beta. Hence I will get alpha to the power n minus 1 into 1 plus root 5 by 2 plus 2 minus beta to the power n minus 1 into 1 minus root 5 by 2 plus 2 upon alpha minus beta is clearly root 5, and this is equal to alpha to the power n minus 1, and this becomes 5 plus root 5 by 2 minus beta to the power n minus 1 into 5 minus root 5 by 2 whole upon root 5. This is equal to, now taking root 5 common from numerator, I will be getting alpha to the power n minus 1 into root 5 plus 1 by 2 minus beta to the power n minus 1. I will be getting root 5 minus 1 by 2. And when I have taken root 5 common from numerator, this has got cancelled with root 5. And I get now alpha to the power n minus 1 into alpha minus beta to the power n minus 1 into minus beta. That is, I get the answer alpha to the power n plus beta to the power n. Hence, I can say B is also correct choice. Otherwise, the alternative way of getting the value of Bn, I can proceed in this way also, that because from here I can say An will be equal to alpha to the power n minus 1 plus alpha to the power n minus 2 beta plus alpha to the power n minus 3 beta square up to beta to the power n minus 1. And now, keeping this result in mind, I get the value of a n plus 1 as alpha to the power n plus alpha to the power n minus 1 beta alpha to the power n minus 2 beta square, and the last will be beta to the power n. And this implies that a n plus 1 is equal to alpha to the power n plus beta to the power n, and from these terms I can easily take alpha beta common. I will get alpha to the power n minus 2 plus alpha to the power n minus 3 beta, and the last will be beta to the power n minus 2, because here the last term is going to be alpha beta to the power n minus 1. Therefore, when I will take alpha beta common from all these terms, I will be getting beta to the power n minus 2. And this is equal to alpha to the power n plus beta to the power n plus. We know that the value of alpha beta is minus 1, and it is clearly a n minus 1, because when power was alpha to the power n minus 1 and so on, then the name was an, and when the power is n minus 2 and so on, the name will become a n minus 1. And because this is a n plus 1, from here I get a n plus 1 plus a is equal to alpha to the power n plus beta to the power n. Hence, after converting beta bn in terms of alpha and beta, I get this. Hence, I can say B is correct choice. Now I am going to check this. I can find the value of this by 3 methods, but presently I am telling you only 2 methods because third method is a bit lengthy. First way is, because alpha is a root of this, therefore I can say alpha square minus alpha minus 1 is equal to 0. That is, I can say alpha square minus alpha is 1. And now multiply the whole equation by alpha to the power n minus 2. I'll be getting alpha to the power n minus alpha to the power n minus 1 is equal to alpha to the power n minus 2. Similarly, because beta is also the root of this, I can reach at the conclusion that beta to the power n minus beta to the power n minus 1 is equal to beta to the power n minus 2. And now, actually what I am going to do, you will understand in next step. Now I subtract the two equations and divide the whole equation by alpha minus beta. I'll be getting alpha to the power n minus beta to the power n upon alpha minus beta minus alpha to the power n minus 1 minus beta to the power n minus 1 upon alpha minus beta is equal to alpha to the power n minus 2 minus beta to the power n minus 2 upon alpha minus beta. That is, I get the conclusion that this is an minus a n minus 1 is equal to a n minus 2. And now for n right, n plus 2, I'll be getting a n plus 2 minus a n plus 1 is equal to a n. And now to get the sum of a1, a2, a3 and so on, first put n equal to 1. I'll be getting a3 minus a2 equal to a1. Again putting n equal to 2, I will be getting a4 minus a3 equal to a2. And because I have to find the sum of a1, a2, a3 up to an, if it is an here I will be getting an plus 2 minus a n plus 1. And now add all the n equations. In right hand side we will be getting a1 plus a2 up to an. And when I will add all these, clearly a3 will get cancelled, a4 will get cancelled, an plus 1 will be getting cancelled with an plus 1 here. Therefore, this will also get cancelled. Hence, sum of all these terms will become a n plus 2 minus a2. Hence, it is clear that sum of all these terms is a n plus 2 minus a2. And now, it is clear that a2 is equal to alpha square minus beta square upon alpha minus beta, that is alpha plus beta, and the value of alpha plus beta is 1, because alpha and beta are the roots of this. And putting this value of a2 here, I get the answer a1 plus a2 plus a3 up to an is an plus 2 minus. Hence, I can say C is also correct choice. To calculate the choice A, I can easily take the help of this, because this has been checked as correct. Therefore, using this result, n is equal to 1 to infinity alpha to the power n plus beta to the power n upon 10 to the power n. And if I sigma on this and this separately, I'll be getting alpha to the power n upon 10 to the power n plus n is equal to 1 to infinity beta to the power n upon 10 to the power n. That is, this is alpha by 10 upon 1 minus alpha by 10 plus beta by 10 upon 1 minus beta by 10. That is, I get alpha upon 10 minus alpha plus beta upon 10 minus beta. This is equal to alpha into 10 minus beta plus beta into 10 minus alpha upon 10 minus alpha into, and just now I had calculated the value of this as 89. And now from here I can say 10 into alpha plus beta minus 2 alpha beta upon 89. 10 alpha plus beta is 1. Alpha into beta is minus 1, therefore plus 2 upon 89. That is the answer is 12 by 89. But the choice A says 8 by 89. Hence I can say A is wrong choice.